Let f be the function defined by f of x equals ln x over x. What is the absolute maximum value of f? So we have this function f of x, and we need to find its maximum value. So to do this, let's first take the derivative of f of x, f prime x, so that we can find critical points. So to take the derivative of this, we can use quotient rule. So quotient rule says the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator. The derivative of x is just 1, so we can just leave it as ln x, and then divided by the square of the denominator. So let's simplify this a little. So x times 1 over x, that's just equal to 1. We'll just have 1 minus ln x in the numerator, divided by x squared. So now that we have the derivative of f of x, we can solve for the critical points. So to solve for the critical points, we have to set f prime of x, the derivative, equal to 0. So we need to find where 1 minus ln x over x squared is equal to 0. So the first step to solve this, we can multiply both sides by x squared. And normally you won't be able to do this because x can be 0, and you can't divide or multiply both sides of an equation by 0, otherwise you might lose solutions. But in this case, since our function has ln x, that means that x, the domain, has to be greater than 0, because you can't have a negative number in the argument of a natural logarithm. So the domain of this function is already greater than 0. So by multiplying both sides by x squared, we won't actually be losing any solutions. So 0 times x squared, that's just 0. So we're left with 1 minus ln x equals 0. So this just means 1 equals ln x. We add ln x to both sides. And then we can just exponentiate both sides. So on the left-hand side, we're just left with e raised to the 1. And then on the right-hand side, since e raised to the ln of something is just equal to the argument of that ln, so that means x equals e is our only critical point. So that means that f of x only has one critical point at e. So now we can draw a number line to see what are the intervals where f of x is increasing and decreasing, where we know that f prime of x is 1 minus ln x over x squared. So first let's test points to the left of e, between negative infinity and e. So we can take something like 1. E is roughly 2.7. So to the left of e is just 1. So if we plug in 1 into f prime of x, so f prime of 1, we get 1 minus ln of 1 and e raised to the e. So the ln of 1, that's just equal to 0. And then we're going to have to divide that by 1 squared, which is just 1. And so this just gives us a value of 1, which is greater than 0. So on the left-hand side, f prime of x is greater than 0. So that means in this interval, we are increasing because our first derivative is positive. Now, on the other side, here, let's make some more room here. So on the other interval from e to positive infinity, we can choose a value like, we can do e squared. we know that e squared is greater than e, and this will make taking the logarithm, the natural log of e squared, much easier. So if we're taking f prime at e squared, so we're going to plug in e squared for x. So we'll have 1 minus ln of e squared over e squared squared. So that's just going to be e to the 4th. Okay. And then the natural logarithm of e squared, we know that when we have the argument being raised to a power, we can move it out to the front as a coefficient. And we know that the natural logarithm of e is just 1, and 2 times 1 is just 2. So we're just going to have 1 minus 2 over e to the 4th. And so this just equals negative 1 over e to the 4th, which is less than 0, because we have this negative sign. The numerator ended up being negative, and we know that e raised to the 4th power is just some positive number. So that means on the right-hand side, we are decreasing, because f prime of x on the right-hand side is less than 0. The value of the derivative, which is the slopes of the tangent, are less than 0. So on the right-hand side, we're decreasing. So that means our function probably looks something like this. It's increasing, and then at the value of e, it stops, and then we're decreasing. It could look like that, or it could look like this. It doesn't really matter, but the point is that at e, the function goes from increasing, so positive slopes, and then we go to negative slopes at that value, at that x value of e. So that means e has to be a local maximum, and since it is the only critical point, it's our only local maximum, which makes it the absolute maximum of f of x. So the absolute maximum of f occurs at an x value of e. So this occurs at x value of e. But the question asks us to find the absolute maximum. So that means we need to find the y value at this x value of e. So if we plug that in really quickly, we'll do it down here. When f of x, where x equals e, we'll have the natural logarithm of e divided by e. And we know that the natural logarithm of e is just equal to 1, and we're just going to have that divided by e. So that means that the maximum value of f is equal to 1 over e at an x value of e. So B is the correct answer.